Hi, everyone, and thank you for joining me. Today, we're talking about DevOps for frontend beyond desktop browsers. My name is Max Gallo. I'm a principal engineer from London. I work at Dazon. You can find me on Twitter at _MaxGallo. The topic of today is quite a big topic, and I want to smash it in three different parts. At the beginning, we will set the context. We will define what beyond desktop browsers mean, especially in the Dazon context, in the live sports streaming context. After we've done that, we will tackle the journey to DevOps. So how did we arrive to the DevOps as we know today? And which are the features that we can steal, that we can borrow from the backend DevOps to the front end? And at the end, we're going to see how those features are actually applying, if they are applying for the front end. But let's start beyond desktop browsers. Dazon is a live sports streaming company. So we serve live sports all around the globe in so many devices and in a lot of countries, more than 200 countries. Among all these devices that we are targeting, there are almost 25 of them, which are HTML and JavaScript based. So it means that we are running our web application into some kind of browser, which is embedded into the device. But which devices are we talking about? So I'm mostly talking about your TVs that you have in your living room and your gaming console, your latest and shiny PS5 or Xbox, or maybe a set-top box that comes with your network provider, and actually maybe more. We are currently supporting more than 25 of them. So in all these idea, we are with all these devices, we created our workflow as it follows. So we started from feature teams. This is our workflow, let's say up to 6 months, 1 year ago. So our feature team were working on common features. So all the common feature which were shared across multiple devices were starting from here. We had multiple feature teams, and once they were done, they were handing over the code to the devices teams. These teams' goal was to make sure that the app was working fine on the device itself. And once the device were happy, all the devices were happy, we were able to go finally to customers. So the idea is that feature, then devices, and then customer. But this particular setup has its own challenges. And I want to start with the first challenge, which is a slow feedback loop. Why a slow feedback loop? Mostly because we have two different teams that are needed for going to one place into another one, and to go from the local idea of this feature to our customers. So imagine any bugs or any feature that goes from one team to another one. If you find any problem, it has to go back. And this goes on and on and on. And you basically have these two teams constantly talking between each other. So that could slow things down. Challenge number 2, work visibility. Imagine the best case scenario. You have one Jira board for the feature teams and one Jira board, let's say, for the device teams, but also we have multiple feature teams. Actually, they are split by domain. So different domain teams working on all the features on that domain, which means that we have a bunch of Jira boards here, and then few Jira boards here as well. So answering the question, when is this feature going to be released, is not that easy, because you have to create a puzzle with all these pieces scattered in multiple places. Challenge number 3, devices teams can't fix issues properly. Why? Because they do not own the feature. In a sense, if a feature team is owning their code base with that feature, then they hand over that feature to the device team to make sure that it works on the Fire Stick, for example, on the Amazon Fire Stick. And device team says, it doesn't really work well. I tried to fix something, but there is this bug. And it means that they do not own that feature. They have to go back to the feature team. So ownership for the device team is actually quite a problem. I want to recap the challenges before we move on. So first of all, slow feedback loop. This ping pong of bugs and feature between these two teams. One is testing on devices, the other one is working on more generic feature. But then we also have work visibility, which is not super clear when a feature will be released, or at least is not as straightforward as we would like to be. And then we talk about device team ownership, because this shared ownership between feature and devices is not playing really well, because it's a shared ownership, which usually means that no one's own anything. So this setup brings us to the journey to DevOps. And I want to start the journey, as every journey, with the first step. And the first step is a quote from the DevOps handbook that says that the first way, emphasize the performance of the entire system. So not just focusing on the silos of different parts of silos of work or department, but focus on the entire system. And if we apply this one, which is like page 1 of the DevOps Handbook 101, we have our old system, which goes from developing a feature to the customer, which has an handover between feature teams and device teams. So we prepare something, we hand it over, and this team check that everything is fine. So if that runs, if they are able to say, okay, this runs, we go to customer. But we have been here before. We have seen this. And what if I call this team here development? And what if I call this team here operation? Isn't that very similar? Isn't that exactly what was happening, let's say 10, 15 years ago, when development team were all about shipping their code as fast as possible without really care if that code was breaking production or if it was too expensive for that machine to run 24/7, to run so many hours of uptime. And then we have operation, which had to cope with just development team shipping features that they may not even were working on some of the devices, some of the servers that they were supporting. And so we had this problem of handing over. And my real question here is that, okay, these are very similar, but in order to push forward this similar setup, how did we arrive to the DevOps that we know today? So we improved a lot in the last 10 years, but how did we arrive to what we know as today's DevOps? And I think there are many contributing factors, one of which is, for me, are abstractions. And abstractions are something very powerful. If you think about cloud providers like AWS, Google Cloud Platform, they build some services on top of servers, on top of databases, on top of many things that developers and operation used to deal with in a very different way. But by building these abstractions, we were able to make teams more autonomous. And that's not only about cloud providers, because we have so many tools like Terraform, Puppet, Ansible, all of them are going and went into the direction of making people autonomous, making teams autonomous. So creating this layer of abstraction on top of our bare metal servers is what, in my point of view, helped develop the DevOps culture. And so the right question to ask at this point is, if these abstractions were so powerful for the DevOps principle and movement in general, which are the abstractions that we need in the front end? And finding out the right abstraction is a very complicated subject, because abstractions are very easy to be created in the wrong way. There is a nice talk from Alex Martelli, The Tower of Abstractions, which highlight how dangerous could be sometimes to take the wrong turn, to create the wrong abstraction. So to answer that question, I want to enter the last part of our journey, which is DevOps for frontend. So when we think about DevOps for frontend, we have most importantly about the right question to ask. Why can't our team be autonomous? Why can't they work on Xbox and on PlayStation 5 and on your Samsung Tizen at the same time? Mostly because there are differences, and those devices are not the same, and they are far from the same. So the pain points that we have in the front end, in this specific context of the devices these days, is that each single of these device has different APIs, a different runtime, a different browser engine, a different video player. So all this difference makes very painful for a team focusing on a feature to be distracted by all these differences. So what if we create some sort of platform team or a team that takes care of these differences and tries to ease these devices' differences? The idea is to enable feature teams to develop and deploy autonomously. But so how do we do that? Because a TV is a complex device, in a sense that you have a development mode, a debugger mode, and then you have the build time when you're building an application, then you have the runtime when you're running the application using your remote or using your controller. So how did we tackle that? We did tackle that in two steps. The first abstraction that we created is at build time. So focusing on tools. Develop on device, it's something that has to be standardized, because if you're working on the latest feature that you want to add to Dazon in this case, but to any service or product that you're building, develop on device is an opportunity to spot all the bugs straight away. And if you can easily develop on device without caring about devices' differences, that's a big win. That's a huge win. But also debugging on device. What if you have a problem and you want to put a breakpoint? You want to go inside that loop. So debugging on a device is something that is not standardized. So we created an npm run dev, where you can pass some parameters, and it doesn't care if that's running on a PS5 or on an Xbox, because that complexity has been abstracted away. But also we worked a lot of monitoring, and especially we focused on test automation. Especially in this COVID time, being at home, it's not easy to work on devices. So we pushed a lot on a TV lab that we have, where we can run automated tests on the TVs and on the devices themselves. And all of that is completely driven by automation and by code. So you write your test, and instead of running on a normal browser, they will run on the device itself, even if it's not there with you in your room or in your home office. They are in the TV lab, but they are running the tests for you. And that's crucial to make sure you have confidence of shipping to multiple devices. That was the first layer of abstraction. The second layer is at runtime. So while your app is running, what happened on the runtime? So on the runtime, you have the first differences are with remotes and controllers. Imagine that a PlayStation controller has to work somehow in a similar way to your TV remote, because they are controlling an app, which is very similar. And also, the developers who are building the features within the app, they do not care you're using it from a PS4 or from a TV. So abstracting these differences goes always in the direction of making team autonomous. And if we extend that knowledge, all the devices API are abstracted away in our runtime. So teams working on features, they just call something which is standardized. They do not care about device differences. And that's true for networking API, since we deal with live videos. Networking is so important for us, but also for putting your app in background when you have a notification and you open another game, maybe on your Xbox. So all of these are all solutions that we put in place to enable feature teams to be autonomous, enable feature teams to go from developing their specific feature to testing and seeing their changes on the devices to our customer, with the help of the tools and the solution from the TV platform team. So feature teams being autonomous, going to customers. But the idea is that, okay, we are creating some parallel ideas. We have some parallel ideas between the DevOps and actually this front-end set up. Can we push it even further? Can we actually say, okay, let's take some DevOps principle like maximizing the flow, and let's see if that applies? And the answer is yes, it does. Because when we take the flow from end to end, we should focus on, as DevOps principle, make the work visible. But if we have one team working on the feature, shipping value to our customers, their work is visible in one Jira board. So that as easy as it can get. You can see the work flying from one column to another one up to when it reaches customer. And also reduce the batch size. Not having to deal with two teams and all the communication between these two teams means that one team can potentially deploy multiple times a day. It's up to them. They are in charge. They are, again, autonomous. They are autonomous into taking that decision. And last but not least, prevent the effect being passed downstream. That is possible because of the tools, because of the solutions that we created. And if we start from develop on device very early, you immediately fix the bug straight away because you see that that round thing is not that round. Maybe you want to fix them straight away. And if you're developing on device, you will fix that in seconds, not in sprint. And once you have that, you can move to testing automation, because maybe you work and you develop on an Xbox and you want to make sure that your PR, your pull request, still works on a PlayStation 5. So why not running the test in our TV lab for checking that PlayStation 5, it's fine. That is possible because we heavily invested into these kind of things, these kind of tools to enable teams to be autonomous. So to recap, how did we maximize the flow? We started by having one Jira board to make the work visible, especially around features. And once you have one team that deploys often and then deploy autonomously, you can truly start by develop on a device as early as possible and add testing automation into the mix. I want to leave you with a few ideas in order on what to do, what to take away from this talk. And I want to say as the first thing that the developer experience is so important. It's even more important when you have a really crappy one, like working on devices. It's not as smooth as, for example, working on web, when you have many more tools, many more solutions already in place. So focus on your developer experience is important. Providing the right tools, spending time for building those tools is very important. And then DevOps is about unifying, but more importantly, is about enabling, is about making teams to be autonomous, making teams responsible of the end-to-end, because a team that is responsible is able to be on call for that specific feature, is able to support that feature with the tools and with the solution that we put in place for them to be autonomous. And then the backend is just the beginning, because we saw how these particular principles are applying quite well, if you ask me, to the front end as well, to the front end teams. And once you have all of this set up and in place, you just have to measure, to improve, and repeat. That was the last slide. I want to thank you for staying here with me today. You can find me on Twitter and at _MaxGallo, and these slides are available on GitHub at Talk DevOps for Frontend. Thank you very much.